Well, thank you for joining us at this session for integration. This is C4 on the Cambridge examination. And when you look at the formula sheet for core mathematics in C4, you will see the formula that you require for integration. Now, you may spot a question that has a question similar to this where it says use integration to find. Now, it doesn't tell you what formula to use, but if you have a look in the formula sheet, you will see there is an integration equation that looks like this, and it's got u dv dx. And this is straight out of the formula sheet. If you look in the formula sheet, you will find this, and it is v du dx. Now, where does this formula come from? You don't have to know, but look, let me just go back and remind you of the product rule. Remember the product rule which says the product rule of u, u, if you've got a product rule, dx of uv, that is u dv dx plus v du dx. Now, if we integrate this, both sides, if we integrate both sides with respect to x, we will have integral of the derivative of u v with respect to x equals integral of u dv dx with respect to x plus the integral of v du dx with respect to x. And you will start spotting where this formula comes from, because if we divide uv and then integrate uv with respect to x, we end up with uv. And we will leave the others as they are, dv dx plus v dx dx. I'm going to take this across to the other side, and therefore I'll just write this one first. The integral of u dv dx with respect to x equals uv minus the integral of v du dx times of dx. So here we have the formula that we're using today, and let's go and have a look at this equation. Knowing that we've got a product here, we've got natural log of x and we've got 1 over x cubed. Now, having a look at this, just knowing that the derivative of the natural log of x equals 1 over x will help us say, well, okay, if we call this one u, if we let u equal ln of x, therefore du dx, the derivative of the natural log of x is 1 over x. You already know that. Therefore, this part we will let the du dx. Du dx is 1 over x cubed. So we want to pick one to be u and one to be du dx. So if we pick this one to be u, knowing that the derivative of that is 1 over x, and this one we will pick to be du dx. So the du dx is x to the negative 3. If we integrate this, therefore, v will be the integral of this, x to the raise it up by 1 and divide by the new power, plus c, but we integrate that, and that is what v equals, because the constant will cancel here. Let's apply our formula, therefore, the integral of u dv dx equals dv minus integral of v du dx dx. And let's substitute. Here we've got the integral of u, natural log of x, du dx, 1 over x cubed dx equals u, which is natural log of x, times v, which is negative 1 over 2, and here we've got x to the negative 2, we'll put that one there, minus the integral of negative 1 over 2 x squared times du dx, and du dx is the u dx is here, 1 over x dx. So we've replaced v with x negative 2 and 2, this is v, and we've replaced du dx 1 over x. Now we're almost finished here with our formula. This is negative natural log of x over 2x squared minus, I'll bring this negative a half out to be positive a half, the integral of 1 over x cubed, and now the integral of 1 over x cubed, we've got it up here, the integral of, we have to integrate that, so that's x to the negative 3. And we did that here, so therefore we will just let that be natural log of x over 2x squared plus 1 over 2, and we already know that's going to be x to the negative 2 over negative 2 over negative 2, and we finish plus c, and we've got negative ln x over 2x squared minus a quarter and x squared underneath plus c. And then we have the answer of A. For part B, we have to, now we've got the same, we already know the integral. Now we have to put this, just insert a new slide here. And let's just delete some of these. So we've got space. And let's write our solution on this page here. Okay, so let's put our solution for the integral of what was it from, we want from 1 to 2, we want the integral from 1 to 2 of 1 over x cubed natural log of x dx. And that will be for, and we're going to go from 1 to 2 of our formula, which is negative a half, we've got log x on here, and we've got x squared underneath, a half, 1 quarter, minus a quarter over x squared, and we go between 1 and 2, so that would be, we substitute 2 in here, 2 times 2 squared is 4, and x squared is 4, and we substitute 1 in here, negative natural log of 1 over 2 times 1 squared, plus negative 1 over 4, and so that would equal, that's negative 160, that's negative 1/8, minus 160, minus negative makes plus, the log of 1 is 0, and then minus negative a half is a quarter, and we have negative log of 2 over 8, minus a quarter, plus 4 over 16, makes plus 3 over 16. Okay, so let's have a look at our solutions that we've got. And let's go through these. So the first answer was negative 1 over 2x squared log x plus negative a quarter x squared plus c. And this was our solution here. You can see we've got that correct on the first slide here. And then the other solution was 3/16 minus 1/8 ln2. So we go back here and see that's 3/16 minus 1/8 ln2. So we've got the correct solution for part B. Okay, we've looked at 2 questions on this session, this support section. So I hope that you can find other questions very similar. Give it a go. Remember, this is in your formula sheet, so don't try and memorize it. Just use it. Just know which parts you use can do and which parts you use for the DDX, and then apply your substitution in the correct place. Until I talk again, stay happy and